So we started to discuss something about something called the relative motion. Relative motion. So we'll start from the basics till the others come. Right. All right. So tell me, if something is in motion, what's the main observation that you could see, or the main observation that you could have? If something in motion, let's say this bottle right here, is it moving or is it stationary? You're gonna say it to be stationary. Why we say so? Yeah, there's no movement. How you can confirm that there's no movement? Yeah, obviously you can see that, right? But how you can say in kind of a mathematical way, if something moves, it's supposed to be like this time to time, which means its position has to change with respect to a certain time, right? So which means it is displacing with the time. And if something displaces, we can define the parameters called the distance, the displacement, and the speed, which you have learned for the O levels. And yeah, the velocity. What's the difference between velocity and the speed? Speed is a scalar, right? So you shouldn't have yourselves to be formatted after the O levels, I guess, right? So you kind of have the idea, right? We have discussed about it, right, in the beginning part of this motion session, right? And yeah, kind of that's the idea. If something moves, the position has been changing with respect to time, so we can define the velocity, displacement, speeds, and also the accelerations, if you can remember, right? And something called the decelerations too. The opposite of acceleration is the deceleration. Yeah, those parameters. And we have dealt with five formulae, related to linear motion. So there are different types of motions as well, right? Apart from the linear motion, we have considered about yeah, something like this. Uh, Come in. So these kinds of motions, guys. What sort of that? What sort of motion is this? It's a rotational motion, right? And sometimes it could be like this. What's that? Yeah, that's something called harmonic motion. Or it's just like repeating the same movement again, again, and again, right? So it's called a simple harmonic, or just harmonic motion. We can learn about it in the third lesson, right? So anyhow, there are different types of motions. When it comes to the motions, don't worry, I'm just giving a recap for them, right? So when there are different types of motion, we can say the position of a certain object changes with the time, right? That's the overall idea. And we were discussing about these parts. Like we have finished up this linear motion part with something moving linearly. What are the parameters dealing with? So there we have learned about that five formulae, right? And something called motion under gravity, and that's something like this. This is a motion under gravity, right? Just falling freely, right? That's the whole idea. And the projectile, something called projectiles, when you just throw something like this, it's going to be a projectile with a horizontal movement and also a vertical movement. So you can see a curved path in that case going like this, right? And we have finished them too. Finally, we are at this part called the relative motion, and it's the last day of motion. And luckily, guys, uh, you don't need to know anything at all from the previous part to learn about the relative motion. So that's an advantage for you too. Uh, because relative motion, we are kind of learning some new concepts. Relative means what? Something relative. Yeah, we need to have a certain comparison. We are expressing a motion of an object with respect to another frame or an object. So the best example we took last day was this one, which to be a certain passenger sitting on the bus, and this is the other guy who's the conductor just walking forward, right? Ticket gunner, like that, right? And this is the bus. And yeah, we had another observer on the earth. Hmm, yeah, last day I had drawn with a cap too, right? So this is the other guy. That's the A. This is the C we have considered, and this is the A, and this was the bus, right? And let's say the bus is moving with a velocity of, I think I gave you last day to be 20 meters per second, and this conductor right here was moving forward with 2 meters per second, right? And I could be able to describe the motion of a certain object with respect to another object, and the notation that we use there is something like this. That's v, that's the velocity. If I just write it like this way, oh, I just write it like this, okay, fine. What's that? It's the velocity of A relative to E. That's the overall idea, right? That's how you read it. Or if I just say like this, bus E, that's the velocity of bus relative to Earth. So in this case, I have some frames here. This is the passenger, and C is the conductor, and bus is the bus, right? I use this bus. Oh, you don't need to name that one. And also there's this E, which is the Earth or an observer on the Earth, right? So what's the velocity of bus relative to Earth then? Which means we should think of the east perspective. We should see about the bus. What do you see here? When observed from the E is just a guy on the earth looking at the bus, and the bus is moving forward. So this guy sees the bus to be moving forward with a velocity of 20 meters per second. That's all. Is it clear, guys? Observer on the earth sees the bus is moving forward or maybe to that direction with 20 meters per second, right? uh, what if I write like this? How you name it or spell it? Velocity of A relative to E. That's the idea, right? So velocity of A relative to E is to which direction? Yeah, bus is moving forward, and this is just a passenger sitting on the seat. So he's also moving with the 20 meters per second, right? Like that. And what is this one? Read it. That's the velocity of C or the conductor relative to Earth. What that has to be. So let's say this is to be a bus with like large shutters, and this guy here sees the bus is moving forward. So as inside the bus, there's this conductor moving forward with 2 meters per second, or with that thing, right? Click, 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 like that, right? So so 20 meters per second from the bus, plus there will be 2 meters per second of the conductor. So altogether it will be 22 meters per second, right? So what if the other way, guys? If I just write like this, what is that? That's the velocity of Earth relative to A. What has to be? Now we need to go into the bus and see from the A's perspective, looking outside, what they will see. It's going backwards now. When you are within a bus, you're gonna see the things are moving backwards, right? When you see outside, trees, houses, all are going backwards. So this going to flip the direction. That's the O. That's the difference, right? It's going to be 20 meters per second to the other side, right? So when the observer and the reference or reference frame interchange, only the direction has been changed. Right? Magnitude wise they are the same, but only the direction changes from this side to the other side. Right? That's the overall idea we have considered last day. Right? So you can have that knowledge to continue with the today's part. Lucky you guys, right? Great. So I told you we have written here, guys, the 22 meters per second, right? Which is to be the addition of the 20 plus 2. If it's not hot, could you please close the windows? I think reduce the noise a little bit. Okay. Great. So the thing here is, if the velocities are to the same direction, or maybe one to the opposite direction, but still horizontal, yet you can add or subtract, right, to the same direction or maybe to the opposite directions, like Egyptian dance, right? So, but the things kind of be weird because if one velocity will be to another direction, the example that I took here will be, let's say, another person while he is on the ladder of that bus, right? The bus was going forward, right? Now let's say this guy right here trying to climb up along the ladder, right? Maybe with a velocity of 4 meters per second. Now how we can express, now let's say this is the, uh, yeah, okay, this is to be that guy, you know, right? I'm representing the Spider-Man here, right? Okay, so yeah, and then whatever, right? So he's just climbing up along the ladder. In that case, if I try to express his velocity, which is the velocity of the Spider-Man, relative to Earth, then that's the problem we need to face, right? Because this guy is moving up while the bus is going forward. Now it's a little bit chaotic, right? So we are going to deal with these kinds of scenarios today, and how we can we are learning how we can express still the relative motion of the objects with respect to another. Also some moving frames. Now in this case the earth was kind of staying there and just observing the scenarios. But what if the earth is also moving? Not the earth actually, but the person on the earth is also moving and observing these scenarios. Then again it's going to be a little bit complex, right? So let's learn about a certain principle that we can apply for these kinds of relative motion, right? Okay, great. So last day we have finished the note for this one. I think you can just leave one page, I guess. You can maybe write the topic relative motion, and thereafter you can leave some space. Maybe one page will be sufficient. Okay, so today we're going to be learning about something called the principle of relative motion or principle of relative velocity. Okay guys, so we write the topic then, principle of relative velocity, or you can write principle of relative motion. The topic quickly, principle of relative velocity or principle of relative motion, right? Both can be used. Okay, so it's something like this. We'll write, when the velocity of a frame, when the velocity of a frame when the velocity of a frame slash object is expressed relative to another frame slash object, the following principle of relative motion can be used. The following principle of relative motion can be used. Well, it's really simple, guys. All you need to know will be a little bit about the vectors. Yeah. Blue pen. Yeah, okay, sure. Hold on. This institute is too much of resources, so I can. Blue pen. Check whether this works. If not, I can give you another one. Right, okay, great. So, as I told you, all you need to know about will be a little bit about the vectors. If you don't know about it, that's totally fine too. I could express something like this, velocity of like this. I told you there will be several notations that you can use without the bracket or maybe with the bracket. No issue, right? What do you prefer, guys? Without the bracket or with the bracket? With the bracket. Shall we roll it? Okay, so anyhow, yeah, you can put whatever you like. I'm gonna go with like this, right? And since these are vectors, because velocity is a vector, I should mark the direction too, or maybe represent it as a vector. So I have represented here the velocity of A relative to B. That's the notation we use. And that is going to be equals to velocity of A relative to C plus velocity of C relative to A. That's something like this. Pretty simple. It's like the vector AB is equals to the vector AC plus the vector C. Oops, B. This is B. CB. It's something like this again. Starting from A goes to B, let's say, then maybe B to C. So where's our destination? That's the C, right? Started from A, we have finished at the C. So all the way we have moved from then the A to C, which gives something called the resultant, if you have heard about it. Well, this is called the principle of relative velocity, which means you're gonna see here, I need to represent the velocity of A relative to B. And there's this third frame, which is the C, that's sneaked in, giving you the link between the two vectors, right? So, which means you can express the relative motion of a certain frame with respect to another frame with the help of a third frame, which is the C here. Got it? Great. So that's the idea. So we write it. If it's not, don't worry, we're gonna do some example questions. So you can get it from there too. For the time being, we'll just copy it down. And what I have drawn in this red color, you can use a pencil or whatever, maybe not something highlighting, but just to show the link. Okay, if you have written this one, we write underneath just a point. You know that we are not going to write very lengthy notes, right? Instead, putting some points and copying down the important points. Okay, so we write uh, the relative motion between two frames. The relative motion between two frames. Relative motion between two frames can be expressed with referring to with referring to a third frame. With referring to a third frame by the above relationship. By the above relationship. Okay, now we're gonna do some example questions. Starting with the first one, I have given you the VCA equals 15 and VBA equals this much. So you should find out the velocity of C relative to B, right? And the second one, yeah, copy down the first one and you can try there, and we'll do the second one. Somebody has fainted? No? This is Z, right? Z, by the way. Let me do the first one for you, like the English paper, right? First one has done for you. Okay, so it's VC relative to B, that's equals to VC relative to, there has to be the third frame, which is what here? C is there, B is there, and additionally we're going to have the A. So you can write velocity of C relative to A plus velocity of A relative to B, like that. So these arrows represent that these are vectors. That's the overall idea, right? I think you have, are you guys doing maths or bio? Maths, bio. You too? Oh, okay. But I think, have you ever seen this one? Have you? No? Uh, Again, I'm just saying, right? There's an 8-hour class in the YouTube merging 3 classes together that gives all the idea about the vectors that we did, right? Maybe I can provide you the tudes too, but not now. I don't have the vectors tude. But still, you can go through that part. Not the 8 hours straight, right, without editing anything, right? You can just split the class maybe to 3 days. Then it's just going to be 4 hours per day, which is manageable, right? Yeah, as I told you, still you can watch maybe the cartoons or maybe you can go anywhere, like still, because it's the very beginning. So this year, guys, make sure you go for every the family trips and maybe every yeah, whatever, right? They request, right? Because the next 2 years you won't be able to go anywhere at all, right? And make sure you watch all the cartoons, all the episodes, and you won't be able to watch them 2 years within the 2026 and 2027. Still, you will have the chance. And meanwhile, balance the work. Okay, great, like this. So velocity of C relative to B. So I should find out the velocity of c relative to a. That is straight away given. So it's just 15 to this side plus velocity of a relative to b, guys. Here's the issue. We have given the velocity of b relative to a, not the velocity of a relative to b. What we need to do? We need to flip the letters. If you need to flip the letters, see, I need to have a relative to b, not the b relative to a. I should flip the letters, which means I should flip the observer and the object. It's something going to happen, like the velocity of bus or velocity of a relative to e was to this side 20 meters per second in the early example. Velocity of e relative to a flips only the direction, but the magnitude keeps the same. That's going to happen in here. I could flip the letters if I could flip the direction of the vector here, so that it is going to be 8 meters per second, not to this side but to the other side, like that. Got it? And I'm writing below, it's just 50 meters per second to this side plus, or else I could put minus and again flip the direction to this side, 8 meters per second. You know how the vectors works, right? It's just AB vector is equals to minus BA vector. If you need to flip the direction, you are putting a minus sign in front. So this I have flipped to get the velocity of A relative to B. Instead, I have given with the velocity of B relative to A, which is to this side. So I have flipped the direction, so it has to be like this. But I can turn into the same direction as this 15 by putting a minus. Got it? So it is going to be just 15 minus 8, which is the same direction, 7 meters per second. So this is the velocity of c relative to b. So make sure, guys, you are correctly marking the direction here. It's really crucial because that's what all determine the plus or minus. And for the first example, follow the exact steps. Don't omit any, right? And if you are wondering how this came, it's like this. This is a side note there. Well, it's okay. You can just skip some of these steps if you are like very confident enough in flipping the vector. Um, I have used like putting a minus sign and flipping the two the references frames. I could write the PQ, but instead I have given it the Q relative to P. So I should flip this to get it like this. So it has to be just 50 to this side. You can straight away write here, guys, right? Without writing these two steps. May steps දෙක ලියන්න නැතුව you can write here. No issue. Still it works. If you need to write like QR, we have given the RQ, so flip it. Comes like this. Without these two steps, guys, may steps දෙක නැතුව, you can directly write like this if you need. Not if you need, but if you are confident enough. If not, just write the steps. Any doubts? Okay. Velocity of period this side 50. Okay, fine. Q relative to R. Q relative to R means you need to flip it. So this 20 has to be flipped within this side. Are you okay with this? Like 100% or maybe like හොඳටම තේරෙනවද නැත්නම් shape the call නැත්නම් set නැහැ වගේ shape මොකද්ද නිකන් අර තේරෙන්නේ නැහැ වගේ තියෙන එක conflicting part එක අර මේක flip කරන එක මෙතන මේ දෙන්න කියන්නේ මේ තියෙන letters දෙක flip වෙනකොට වෙන්නේ මේකේ direction එක change වෙන එක විතරයි වෙන්නේ. So you need to have velocity of p relative to q. But we have given the velocity of q relative to p now. So I could make here මෙතනම හදා ගන්න පුළුවන් velocity of p relative to q to where this 50 to this side has to be flipped to the other side. Okay with that? And I should have here the velocity of q relative to r, but I have given the r relative to q. So from this one I can make velocity of q relative to r is going to be flipping just the direction, it is to the other side 20 meters per second. Okay. So all you could do here is write in this step. I'm going to write it above. That is to be to this side 50 plus to the other side 20. So it's like 50 added to this side while just 20 added to the other side. So the overall resultant is going to be to this side. Good. Got it? There's this third one also, guys. This. Nishka, are you okay with this? How I flips the direction? And okay. Let me know anything from there. Ah, you know about Pythagoras, that's good. Are you okay with this part? Right? I'll just flip the direction and the letters are changing. Great. Okay, this part is being erased. The third example. You should find velocity of y z relative to y. That's velocity of z relative to x. That's velocity of x relative to y. Right? So if you are like wondering how you gonna put the x into this one, right? Or maybe the third frame into the equation here. Well, it's something like uh, first having a connection with the maybe your crush friend. So you can make a connection with your crush, something like that, right? So all we need to do here is we need to sneak that third frame in, right? So the friend here will be the x here, right? Making the connection with the other one, like this. There has to be the third frame somehow. You're gonna see here, I should write the velocity of z relative to y, and seen at the other data, there's this other frame x. So you should place it in the middle to convey the messages, right, and the gifts, and all right, something like that. Okay. So yeah, it's going to be like this. Mark them to be vectors. So velocity of z relative to y, that's what we need to find out. Velocity of z relative to x. Now that's already given to upward 60 meters per second. Plus, this should be flipped to the other side, right? I should find this one. So if you need, you can find it elsewhere. That's velocity of x relative to y, and that's going to be to this side, 80 meters per second, like that. Flip in the letters, direction flips. So it's going to be to this side, 80 meters per second. Now the thing is, we don't have the vectors over here, the velocities are not to the same direction. One is horizontal, the other one is vertical, right? And there are a couple of ways that you can simplify these kinds of two vectors which are not to the same direction. And more specifically, there are three methods. What are they? The guys who were at the vectors class knows about it. Yeah, I could resolve, which you don't need to do here because these have been already resolved, right? One is horizontal, the other one is vertical. Yeah, that's yeah. You can draw a vector triangle. That's one method, or else something called the parallelogram law of vector addition. You should be able to say them without looking at the book too, right? Okay, so I'll just show it to you with the both methods. for the reference. Let me draw the vector triangle, guys. So all what I need to do here is, using the two vectors, I should construct a triangle. Well, it's really easy. You can start from somewhere here and represent the 60. And these are vectors, so we need to draw this arrow proportional to its direction and the magnitude as well, which means a shorter arrow for the 60 and a longer arrow for the 80, right? So I'm drawing here the 60. This is my starting point. Let's say it is A. I'm not mentioning anything, right? Let's say it like that. This is my starting point, and this is my ending point of the 60, and I have finished drawing that. Now from there onwards, I should draw the other one, which is the 80. So it has to be like this. This is the 80 meters. And notice here I have drawn a larger line for the 80 rather than the 60. And this is the ending point of that vector. So the resultant should give, by the enclosed figure, connecting the third side like this. Which in this case to be these one is vertical, the other one is perfectly horizontal. So they are kind of making a right angle triangle here. So if you draw this one to a proper scale, you can get the length of the third side, which you can do from without drawing by the relationship of the well-known Pythagoras, right? So you can have here to be the R maybe. So R is of the VR. The VR is going to be 80 squared plus 60 squared root. And I could write it to be uh, 13. 13, is it 13? No, not 13. 10, yeah, 10. So it is 100 then, which you can get from the Pythagoras triple, right? I'm always telling these guys, right? Like this, and then have 5, 12, 13, then 3, 4, 5. What else? 6, 8, 10, and so on, right? So if you can remember that this is 60, this is 80, then it is to be 100. 6, 8, 10, 60, 80, 100, like that. So yeah, like this. So you are not doing a fair if you just find out the magnitude of this and just write the unit. We should express a certain direction as well, which means I could take it to be maybe to the horizontal or maybe to the vertical. Let me take it to the vertical direction, and I should write the tan alpha too, because it is a vector. So we need to write both magnitude and also the direction, which direction this resultant has to be, or which direction the v x relative to z has to be. Oh, sorry, I said the wrong way. Velocity of z relative to y, right? Okay, so it's kind of aligned to this side, and I could write the tan alpha knowing the opposite side and the adjacent side. For this alpha, 80 is going to be the opposite side, and 60 is going to be the adjacent side, right? So it's going to be 80 over 60, like this. So alpha is equals to tan inverse 4 over 3. So you should write like that. That's about drawing the vector triangles. What's the other way, guys? This is one method. Apart from that, I could do it with the parallelogram law of vector addition. Still, I should represent the two vectors. One it is to be this side 80, and the other one is to upwards, that is 60, with the angle between them to be theta 90 degrees. So we know that the resultant has to be in the middle somewhere. That's VR. If I give you a recap on the parallelogram law of vector addition, these are the two vectors. P and Q like this. So what's exactly the parallelogram law of vector addition? Not the bisector. If two vectors are represented as the two adjacent sides of a parallelogram, the resultant of the two vectors is given by fill in the blank. Oh, come on, guys! You're gonna have I told you, right? You're gonna have a test very soon. By the diagonal that you could construct in that parallelogram. So this doesn't have a like this doesn't seems to be a parallelogram, right? Instead, you need to construct one like this. This is equal to this, and this is getting equal to the other one. So this represents the vector P also, this is representing the vector Q. And now you can construct the parallelogram and the diagonal as well. You know what's a diagonal, right? That line goes in the middle. And the resultant given by this. I told you it's kind of hard to construct a parallelogram and see or measure what the resultant is. Instead, we have derived an equation for this R. Anyone? P squared Q squared plus 2PQ cos theta, where the theta is the angle in the middle. Right? Let's come to here. So I can construct a parallelogram, which in this case to be a what sort of thing? Parallelogram will be a rectangle, but still it's a parallelogram, right? I think you have learned it for the O levels. Rectangle is a parallelogram, right? So the resultant has to be like this. VR. Either way, this one vector is going to be the P and the other vector is going to be the Q. Same as the two vectors, P and Q. Now we're going to have the two vectors, P and Q like this. But with the angle not the theta, instead we're going to have it to be 90. Let's put that. So the VR or the R here, I'm going to put R. So R squared is equals to P squared, which is 80 squared, plus Q squared, which is 60 squared, plus 2 PQ, 80, 60, cos theta, cos what? Theta, which is the angle between the two vectors. Now in this case, it will be 90 degrees, right? That's the angle between the two vectors. So cos 90. So what's cos 90? Cos 90 is what has happened, guys? I have given you a chart as well to remember. Why I here always turning the pages? Yeah, this part is 0. So the entire product becomes 0, right? So we're gonna have only to be r squared equals 80 squared plus 60 squared and r equals 80 squared plus 60 square root. And that is to be 100. Okay. What else? I could write the tan alpha 2 for the same thing. You're gonna see here if I draw a vector triangle also that gives the same thing. Or else you could write with the parallelogram law of vector addition. Still you get the same one. Yeah, maybe go with the this. That's the easiest way that you can do this, right? We can go with the parallelogram law of vector addition. That's totally fine. Still, when you're gonna have two, we know this one, right? When you're gonna have two perpendicular components or two perpendicular vectors, the resultant will be the addition of squaring of them. This part becomes 0, so you don't need to consider that one. Okay, we'll copy down if you need both, or more importantly this one. So the tan will be depending on whatever the angle that you choose. If you can, well, you can choose this angle too, the angle to the horizontal. Then the tan will be flipping the two numerator and the denominator. Just flips with the 3 and 4. By the way, guys, how many have you watched a 3D movie? Have you watched a 3D movie? No. No, I mean like going to a real cinema and watching a 3D movie with that the glasses putting on. No, no. So, no. You have? How about you? No, no. Okay, so when you're gonna have the next vacations? I think for the November, I guess, right? For the A levels, isn't it? Okay, so we're gonna arrange our first visit then. You know that there are several batch trips going on, right? The recently going one will be not a batch trip actually, so it's basically we are going to watch a 3D movie. Currently, we're gonna have that Jurassic World, but we'll see what comes when then, right? And then we'll see. So book yourselves for the November, right? Probably we're gonna watch a 3D movie in the morning time, not in the evenings. You can come with your parents too. Okay. Okay, only with the parents, right? you know. Okay, great. Finish with this, guys. Racing. Great. We're gonna try one more. Okay, this is the fourth one. Guys, we'll do it quickly. Come on. So you might be wondering, it's not V. Why it is the A? Yeah, that represents the acceleration. And can we write the acceleration in the same way like this? Yes, it is possible, guys, because I told you this is about the principle of relative motion. Oh, we have really need to be the relative velocity, because most of the time we are dealing with the velocities. But still, you can apply to for any scenarios like the forces or for the accelerations for anything, right? You can represent something relative to another one when they are vectors. Still the same representation, but you need to apply here the A instead of the V. And also flips the direction accordingly, right, if you need. Okay, so what you got for this one? It should be 5, but to which direction? Well, yeah, uh, you can say like acceleration of L relative to n. That's acceleration of L relative to m plus acceleration of m relative to n. You might be wondering, are we not like drawing the arrow upwards because it is upwards, like in this case? Maybe downwards, right? No, guys, this is just to represent that these are vectors. One way of representing a vector is like writing the two letters and drawing an arrow above. So this is to show that these are vectors. In this case, you are not representing them to be here, right? These are not representing the direction, right? And thereafter, you could do like this: velocity of acceleration of n L relative to n, that is given acceleration of L relative to m, and that is to the same direction, fine, with 4 meters per second square second plus this one. Well, it is this one, but instead you need to flip the letters, so it should be directly downwards, right? Then after you can draw that vector triangle, that is the easiest way. So starting with the first known vector, that is 4 meters per second, and thereafter we're gonna have the 3 meters per second square second, sorry. And the resultant has to be the line in joining the starting point and the ending point to that direction. Then you can write here the alpha, whatever, and here it is the a, right? Maybe a l relative to n. A l relative to n is going to be then equals to root 3 squared plus 4 squared, which is just 25. Root will be 5 meters per square second. So write the alpha. I have taken the alpha to the horizontal, so tan alpha is going to be equal to 3 over 4. Then alpha equals tan inverse 3 over 4. So we do it. If you have taken the alpha to the vertical, then these two flips, right? Okay, guys. Pretty straightforward until now. But there are some scenarios you will be given, instead of these specific values, you have given with a certain statement question, and you need to extract what are the frames, and you need to write these data and find the unknown. Let's try one of the questions like that. Let's try it like this. Maybe the example 2. Let's try it. A motor car capital A motor car capital A drives due east, drives a motor car A drives due east with 30 meters per second, 30 meters per second, while another car B, while another car B goes due north, while another car B goes due north with 40 meters per second, 40 meters per second. for 0, right? Find the velocity and the direction of A relative to B. A relative to B. Okay, do it. First of all, you need to know the directions, right? So what's here? The north. Then it is east, south, and west, right? Don't know about it, right? Actually, you don't need to know about that. You don't need to specifically consider about it, true, right? One is going up, the other one is going to this. Yeah, could be. But for the drawing of the vector triangles, you don't need to like have them to be acting at the same point, right? Still, you can represent the vectors to be acting at the same point. So there's a hidden frame here, guys. We should name it. I told you once, right? Last day, if you are taking any frames, just name them. I can take the A to be the car A, and B is the car B. What's the third frame here? There has to be a third frame or third observer looking at these motions. And usually you're going to take it, if it is not mentioned, it is the earth or stationary observer on the earth. Right? So what we have given here, the car A moves with a velocity due east, right? Which means the velocity of A relative to earth is given. To which direction? To this side with 30 due east, this that direction. And velocity of B relative to earth is given due north, yeah, 40. Yeah, good. So velocity of, we should find out velocity of A relative to B. See here, it's not given specifically, but you need to extract it from the statement question that is given. Name the frames first, then mark the velocities. Then you can apply the principle of relative velocity, and that is V A relative to B equals V A relative to E plus velocity of E relative to B, and these are vectors. So velocity of Earth, A relative to A, that is just this side 30 plus E relative to B, you need to flip the direction downwards, 40 meters per second. And now it's time for us to draw the vector triangle. It's going to be 30 to this side, 30, 40. And just 50. Tan alpha equals 40 over 60, sorry 30. So alpha equals to tan inverse 4 over 3. Okay, great. Pretty easy, right? We'll do one more, right? One more question from this part. Right. A monkey, a monkey climbing vertically up. A monkey climbing vertically up in a tree, on a tree, sorry, on a tree with 4 meters per second. With 4 meters per second. While a dog on the ground, while a dog on the ground running towards the monkey, running towards the monkey with 10 meters per second. Find the velocity of the dog. Find the velocity of the dog as seen by the monkey. Yeah, sure. Yeah, we can be. Just leave it there, guys. For the exam, if it is given, the root 29 will be given instead of root 116. Right? You will be given a simplified root rather than the exact root that you're gonna get. Make an MA then exam right? The simplified of the root. So you can write here. This is to be 4 times. Best way to escape out from a square root is making a perfect square inside. So what are the perfect squares you know? 2 squared, that is 4. 3 squared, that is no point of taking 1 square, that is at 1, right? So 2 squared, 3 squared, 4 squared, 16 likewise, right? So you should write each and everything to be a product of maybe 4, or maybe 9, or maybe 16. So here I could check this to be divisible by 4. That's the first perfect square I can make. Yeah, it is divisible by 4. So it is 4 into 29. 4, that means 2 squared, and the 2 comes out. Really easy up to now, right? I mean, not kind of hard thing to. Uh, you don't need to use your brain much in taking this, but things come to be a little bit weird when you're gonna consider something like this, right? Now, all these cases, guys, the third frame here, this is the third frame, right? For an example, here the Earth was third frame. It wasn't moving. There has to be a certain stationary frame somewhere to express the other motion. What if the third frame is also moving? Or in here, what if the person on the Earth is also running, maybe chasing the monkey, right? The dog and the man, both of them are running, which is the Earth here, right? In that case, writing this equation is kind of complex in that scenario, right? So we are going to learn something very basic, and also you can apply to anywhere without even putting this relative principle, right? Relative velocity principle. And let's do it by a certain example. Let's try it like this. We write an example. Actually, we need to draw an example, right? Alright guys, so I'm going to consider three objects which are moving. Let's say this is the A, walking maybe towards this direction. This is the A. Maybe the C, just the C. He's not working, he's just standing, right? This is the C. And let's say another observer, that will be the B. Okay, let's say I'll take some feasible values here. Yeah, we'll take this to be moving to. Okay, so here the A, let's say it is moving to this side with 8 meters per second. to this side, this guy is moving with 10 meters per second, while to the same direction, this is moving with, let's say, 3 meters per second. Okay. So if I need to express the velocity of B, maybe relative to the C, what I should do? Velocity of B relative to C, what I should do? Yes. To express the velocity of B relative to C, we need to take the help of the crushed frame, right? Which means we should take the help of the A here, which is the third frame. And the third frame is also moving to some sort of a direction, unlike the Earth in the previous case, right? So we'll use an easy method uh, to express the velocity of the others relative to the B, right? So I'm going to draw the same diagram, Control C and Control V here, right? This is the C, this is the B, and this is the A. Alright guys, so tell me, if I need to maybe express the velocity of C relative to B, now the B is moving now. If the B is not moving, it is really easy to express the velocity relative to a resting frame or a frame that is not moving, right? So how we can stop the B, or we need to freeze the B? How you do that? Take the Ben 10's watch, become the Shita Bhuta, right? Well, yeah, that freezes, but that's not how we should do that, right? The issue is the B is moving now. That's the problem. If you need to express the velocities of C and the A relative to B, the issue is the B is moving. So we need to make the B to be stopped. In that case, we can express the other velocities very easily relative to resting frame, right? A stationary frame. To freeze the B, what we need to do? Tell me guys. He is having a forward velocity of 10 meters per second. To make him stop, what we can do? We can give him a backward velocity of 10 meters per second, right? Okay. And that's gonna freeze the B. So this guy is having a velocity of 10 meters per second to this side. So I can stop him by giving an opposite velocity of another 10 meters per second. Right? Now the B freezes because the two velocities are to the opposite directions, so they will cancel out. But guys, it's not fair for us to only apply the 10 meters per second velocity for the B. We should apply it for the other objects too, which are in the system, right? Which means this guy was having like 3 meters per second velocity. For that one also we need to add the same 10 meters per second. And this was moving with 8 meters per second, and another 10 should be added to the same direction. like this. Uh, well, sorry about my poor space management, right? I'm just writing it at the below. Can you guys see if I write below? Then the B freeze. Freezed. Right? Actually, freeze. Oh, I'm frozen, right? Whatever. So yeah, to this side then. This A will have a velocity of how much then? Yeah, 10 plus 8 all together. This guy will have to this side 18 meters per second. While the other guy here will have a velocity of 7, but he has to be like turning to the other side. The C, that is 7 meters per second. Got it? So it's really easy. If you need to express the velocity of velocity of a certain object relative to another object, that means we should freeze the object that being referred. Right? So to freeze the B here, I should give an opposite velocity for the B. So not just for the B, but I need to apply it for the other two objects too. So I have represented here by taking the overall, this 18 meters per second is going to be the velocity of A relative to B. What is this 7 meters per second? That's the velocity of C relative to B. Got it? That's how you can express the relative velocity with respect to another moving frame, a third moving frame. All you need to do is freeze the B, or just freeze the third object, or third frame, giving the opposite velocity. Okay, so we write that. First we'll draw this. Only the first diagram, this one. I know you guys really wish that you're gonna have the control C and control V here because you need to draw the three diagrams once again, right? But you can't, so only draw the first one, then we can write a little description for that and moving into the next second and the third diagrams. First draw the very first diagram, this one, the upper one. And guys, it's okay to draw a stick figure rather than my beloved grifty, right? Yeah, sure. Uh, this doesn't have, this has, and maybe a color. Yeah, just the first one. A brown color pencil, do you need one? Only the first one. And thereafter we'll write like this. To consider the motion of A, to consider the motion of A and C relative to B, A and C relative to B, the B should to be stopped. Relative to B, comma, the B should to be stopped. For this, for this, yeah, maybe you can write to the same point. For this, an opposite velocity, for this, an opposite velocity same as the B, same as the B, need to be applied. Need to be applied for all moving frames. For all moving frames. Okay, so draw the second figure and use another color to mark the opposite velocity that I have given. I have marked in the red color. Only the second figure. Okay guys, great. Then we write underneath. Therefore, you can write three dots, right? You know. Therefore, the velocity of A relative to B, you can write VA, comma B. Velocity of A relative to B is 18 meters per second. 18 meters per second, and so as velocity of c relative to a, so relative to b, vc b, velocity of c relative to b is 7 meters per second. Okay, draw the third figure. I know it's kind of like boring too, right? But yeah, things are going to be changed once we see the tuned questions after the break. So we'll finish this part soon. Alright guys, there's something important you need to notice here, and that's about this A and B. Which directions are they were moving? I mean, not the south, east and west, right? I'm just asking, uh, can you guys see that the A and B were moving to two opposite directions? B were moving to this side while the A was moving to the other side. In that case, if you freeze the B, which means if you say the velocity of A relative to B, you're gonna see the velocities are being added there, right? Which means if the two objects are moving to two directions, opposite directions, the relative velocity will be the addition of the velocities, right? And you're gonna see here the B and the C were moving to the same direction, so the relative velocity will be the subtraction of the velocities between them, which I could represent like this. So first we'll write that one in 2 points, and thereafter we'll write a summary, right? First we'll write the points. From this, if the two objects were moving to the same direction, from this, comma, if the objects were moving to the same direction, the relative velocity will be the subtraction. The relative velocity will be the subtraction, or within brackets the difference. Okay, so next point, right? If the two objects were moving to the opposite directions, If the two objects were moving to the opposite directions, the relative velocity will be the addition. The relative velocity will be the addition. You can write summation within brackets. Summation. Okay, like this, guys. So you're gonna see here in this case, if I need to express the velocity of maybe the B relative to A, I should freeze the A. So I should provide a opposite velocity for the A to this side. So it's going to be adding that same velocity for the B as well. And pretty similar for the other one. I should apply a velocity for this side, so as this side, right? So both cases, guys, it's going to be the difference, right? So it's going to be VA minus VB, or the other way, VB minus VA, but it's the difference. Here, guys, if you need to express the velocity of maybe the B relative to A, you need to freeze the A, which means you need to give that VA to this side, and that VA will be added to the B as well. So it's going to add the velocity. This is going to be freezed, and this is going to be adding the velocity to the same direction. So in that case, I could write VA plus VB. Right? I'm going to write it for the first one like VA. So the VA comes to the same direction, and here's to the opposite direction. So you can remember it like this. What? To the same direction, it's the subtraction. To the opposite directions, right? When they are moving to the opposite directions like this, it's the addition of the velocities. The same direction, subtraction. The opposite directions, it's the addition, like this, right? Okay, remember it, not just for now, guys. We need this one for something called the Doppler effect in a future lesson, right? Okay, there I'll give you again this recap, but you need to remember that. Okay, let's draw the summary. This is the summary of the overall relative velocity, right? Overall relative velocity. So just draw this velocity, whatever the thing that we need to like applying for the freezing, right? In a pencil or something like that, right? Mark these velocities to be highlighted. If you need, you can write same direction. Moving to same direction. Here moving to opposite directions. Alright guys. So with that we're gonna have the break. Now it's 2:38. We'll say it to be 2:40. So I'm gonna give you a 10-minute break. Very quick one, right? Just be here by 10. Sorry, 2:50, right? Just come by 2:50. We're gonna be continuing with this lesson until the 4:30, and it's time for us to do some pretty intensive questions, right? Rather than just flip in the letters. Alright guys, now we're gonna try the 49th question in the tune. Page 9, question 49 in the tune. Page 9, question 49. We'll do it soon. Now you're supposed to draw this diagram. It's better you could copy it to your book, the two paths, and you can mark the distances. I'm still letting you to try. Then after we're gonna discuss. Fourth question. If the relative velocity path goes through the B, what's going to happen? Sorry, not B, right? For A goes through A, yeah. What happens? You should describe what's going to happen there in that case. So you don't need to put a comma here. Okay, it's a bracket. Okay, great. Can raise any questions if you need, right? Hmm? Sorry, what? Ah, okay. Okay. I think you will be able to answer the first three part at least. No? Okay. So yeah, we'll discuss. We'll start with the first one. What is meant by considering the velocity of A relative to B? It is asking what is meant by. That means you should write within words. You should write some statement there, not asking what's the value, right? Yep. What is mean by considering the velocity of A relative to B? Enclose it if you need. Relative means we are kind of making the B to be stopped and consider the velocity of A, right? What is meant by means expressing the velocity of A when B is at rest, or when B is to be made at rest. Expressing the velocity of A when the B to be made at rest, or B to be made stationary. That's called the relative velocity, right? We need to freeze the B. Yeah, sorry. Yeah, we need to freeze the A. If it is asking about the relative velocity of B relative to A, you should write with words. That's all, right? Second part. What should be done to consider the velocity of B relative to A? Now it's flipping the letters, which means we should say the velocity of B relative to A, which means we need to make the A to be stopped, right? So it is asking what should to be done to consider, which means applying an opposite velocity for the A and for the B, applying equal and opposite velocity for the A and also for the B, applying equal and opposite velocity of 5 meters per second, then it is good, right? If you need to be somewhat descriptive, you can write like that too. Applying an equal and opposite velocity of 5 meters per second for the A and also for the B. Okay, great. That means we need to make the A to be stopped. How do you do it? It's moving upwards with 5 meters per square second, 5 meters per second. So you need to put a downward velocity of 5 meters per second. And it's not fair if you just apply it for this one. You need to apply it for the other one as well. Like that. Since it is downward, I should apply the same downward velocity, right guys? Okay, great. Then the next part. Construct the path of the motion of B relative to A. Now relative to A means now the A has been frozen like that. So Now the B is moving to this side with 12 and to the downward direction with 5. Right? It's like seen from a drone, right? Initially, these guys were like going like this, right? Approaching to the roundabout, whatever, right? The four-way junction. So construct the path of B relative to A means now the A has been stubbed. Now which direction the B has to go then? They are the resultant of these two velocities, right guys? So it has to be somewhere like this. Let's say this is alpha. That's the path, and you could find the alpha too, right? With the resultant, you could find the velocity of B relative to A, that is going to be maybe to this side, right? Velocity of B relative to A, and that we could find out easily by maybe drawing the two lines. Okay, fine. This is to be 12 meters per second, and below we're gonna have the 5 meters per second. Resultant has to be like this. Or else you can just draw these two as two perpendicular vectors, 12 and 5, sorry, flipping the colors, 12 and 5 like this, and the resultant should be lies in the middle, not exactly but somewhere in the middle, right? Velocity of B relative to A, this is alpha, and we could find that one easily. Velocity of B relative to A, that will be given by 5 squared plus 12 square root, and that is just 13 meters per second. That's the velocity magnitude. So you could find the direction too. Tan alpha is equals to, if this is 5, this is also going to be 5, so opposite or adjacent will be 5 over 12. So alpha is equals to tan inverse 5 over 12. And you should construct the path like that. Right guys? In your diagram, you're supposed to draw it, the path. It is asking construct the path, which means you should construct it. Okay, done. And notice here guys, once you define the relative velocity of B relative to A, now the A is not moving. Remember like that. Now A has been frozen, something like that, right? A is now not moving. That's the overall idea. It is asking the fourth part, what does it imply if this path goes through A? What does it imply if this path goes through A? Yes. I just got a valid answer. Come on guys, I think still you are not within what's called as freezing, right? Or the relative velocity. Now the thing is like this. Okay, let me show it to you. Okay, I have this piece of metal, or maybe like something like, yeah, these. Okay, so this is the A and this is the B, right? They were moving like this. Could be crossing, we don't know about, right? This was moving with 5 meters per second, while this is moving with 12 meters per second. Now it's pretty hard to like see what's going on because the two objects are moving here. Objects දෙකම යනකොට හරිම complex නේ, right? It's really complex to like define the velocities and what's going to happen in there. In in such a scenario, we could just, instead of like moving the two objects like this, we could freeze one object, which here in the A. So A had a velocity of upwards 5 meters per second. Now I have given a downward velocity of 5 meters per second, so the A is not moving now. Now relative to the A, B is supposed to be not moving this path. Now it's supposed to be following a path like this, right? Actually guys, that's something that you have seen in the movies, right? Maybe you have seen that the drive is going like this and there's a vehicle approaching within like inner side of the shutters, right? But the vehicle is moving to this side, the other car is moving to this side. Maybe he's trying to crash the A. While A is driving faster, I was just looking at maybe Fast and Furious movies there to find it quickly to show you guys. I think you have seen in these movies and all, right? The driver is driving and towards maybe driving to the front, and maybe he sees a vehicle approaching him, not by this path, but he's coming by this path, right? මේ path එකේ තමයි එයා එන්නේ. මේක තිබ්බොත් the actual scenario is like this, right? But if you freeze the B, freeze the A, the B seems to be moving not in this path. Now it seems like moving along this path. It seems like that. The driver in the vehicle A seems like the B is coming in a side. පැත්තෙන් එනවා වගේ තමයි පේන්නේ යාට. Right? That's called the relative velocity. But in the real scenario, the A is moving and also the B is moving. But if you try to freeze the A, which means if you are trying to give a relative velocity from the A's perspective, the driver in the A car sees that the B is coming somewhere like this and passing. Got it? Still no? Okay. So the thing is, if you have made to be the A to be stopped, A will be remaining in this position while the B seems to be moving in this path. That's the overall idea. But actually, in the real scenario, the B doesn't like go off road and going across this path, right? It's not something like that. The real scenario, the two vehicles are going like this. ඇත්තටම කතාව ගත්තොත් vehicles දෙක මෙහෙම යන්නේ. ඒ දෙන්න මෙහෙම එන්නේ නැහැ. දැන් මෙයා මෙහෙම ඇවිල්ලා මේ off road පැනලා මෙහෙම ඇවිල්ලා grounds වලින් පැනගෙන ඇවිල්ලා එහෙම යන්නේ නැහැ, right? real scenario එකේ දෙන්නම මෙහෙම යනවා. but ඒක complex නේ අපිට අර motions දෙකක් consider කරන්න ඕනේ. So instead we're gonna define a relative velocity, which means the A is not moving. So relative to the A, the B seems to be moving somewhere like this. ආයෙ කියනවා මේ B off road ඇවිල්ලා යනව නෙමෙයි. Aට පේන්නේ B මේ පැත්තෙන් එයාව approach වෙනවා වගේ idea එකක් තමයි තියෙන්නේ. It's something that you can see from the A's perspective. Right? අර තියෙන්නේ අපිට තියෙන drive කරනකොට මේ පැත්තෙන් එලා ගලා අදිනවා නේ. ඒතර අර side shutter එකෙන් පේන්නේ නිකන් කාර් එක මේ පැත්තෙන් මෙහෙම අපිට approach වෙනවා වගේනේ පේන්නේ. ඒතර cars දෙක මෙහෙම යන්නේ. උඩින් බලන drone shot එකක් ගත්තොත් මෙහෙම යන්නේ දෙන්නේ. Right? කොහොමද ඒක explain කරන්නේ? මට තියෙන්නේ නෑ මොන හරි Lamborghini දෙයක්වත් දාලා මේ වැඩේ කරලා වෙන්නන්නේ නැත්තම්. How do I tell this, right? I tried my best. Maybe I'll make an AI video. I'll try my best, right? To upload it to the group. Okay, so anyhow, now the thing is, now the A is not moving, luckily for us. Huh? So we need to consider only the motion of the B. Now the B is not moving in this path, instead it's kind of seems to be following this path. If I answer the fourth part, it is asking what does it imply that this path goes through the A. That means this dotted line is now going through the A like this. Now remember, we have frozen the A, so the A is not moving. Then that means they're gonna crash. And here, no, they're gonna crash. And here, like that. But we have like made the A to be at rest, so the B relative velocity of the B will be following this path. How do we say if this is crashing at here? We should do a whole lot of calculations there. We need to find the velocity of this is 5 meters per second, so we need to calculate the time taken by the A to reach to this point. At the same time, you can apply another equation for the B and check whether it's covering up that 20 meters to 120 meters within that the same time. In that case, the both cars will be at here, which you need to do a whole lot of calculations, right? Instead, if you freeze the A, now the B is moving along this path, then it seems to be crashing. Again, not at here. Relatively, it will be at here, but the actual case, it will be at here. Got it? Oh, that's what you need to write there. We write. That means the A, which means this implies the A and B are crashing. This implies that the A and B are crashing at the junction. This implies that the A and B are crashing. A and B are crashing at the junction. අර දෙන්නම මූව් වෙනකොට මේක නිකන් හරිම කම්ප්ලෙක්ස්. මේකයි මම එක්කෙනෙක් නතර කරගත්තා. ඒතකොට අනිත් එක්කෙනා හරියට නිකන් මේ පාත් එකේ යනවා කියලා ඔයාලා නිකන් ඉමේජින් කරගන්න තියෙන්නේ. Something you need to imagine. We'll go with the fifth part. Fifth part. What is the minimum distance between the A and B during this motion? Again, if you try to consider the two motions separately, it's really hard for you to find out. But right now, guys, A is not moving because we have made to be at rest. Right? In that case, we know that this doesn't cross the A, right? Now the A is not crossing here. A haraha yanne ya. It will be going somewhere path like this. This is alpha and we have already found that alpha. So guys, what's the shortest possible distance between A and B here? Now again think, A is not moving, B is following this path now. What is the closest distance? Here, 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 or maybe here? Think it. A is not moving now because we have considered relative velocity, so I can consider several distances. Which is going to be the shortest possible distance? The shortest distance between locus of a point and a fixed point. Yeah, it's a perpendicular bisector, right? So which means it has to be the perpendicular here. So I'm going to consider this is to be the D. Like this, right? So I'm going to draw a separate diagram representing all those distances, guys. This is 120, and from here to here it is 150. Oops, sorry. I'll use the same color. This D you need to find out. Yep. You know this, alpha. Let me put some letters here. This is X. So what can you say about this length? Altogether it's 115 all the way up from here to here. And the main distance is 115 now. So this distance right here will be 115 meters all the way from here to here. So this is going to be then, if this is X, this is going to be 115 minus X. So our intention is to find the D, right? Okay. If this is alpha, I could write here this is to be 90 minus alpha. You guys agree with me? No? Okay. Let me put theta here. This is also going to be then theta. Are you okay with that? Why? Yeah, they are vertically opposite. Okie dokie. So we need to find the D somehow. Yes, guys. So here see, I'm gonna have an alpha, tan alpha to be 5 over 12, right? If I could write like that, they are supposed to be a triangle with the alpha with one side to be 5 and the other side to be 12, like that. What's supposed to be the third side? This has to be the 13. We have already found that one, right? From this too. Okay, so coming to here, to this. If I just write like alpha plus theta plus 90 equals 180. Is it okay, guys? Why? Yeah, sum of all the interior angles of a triangle, I'm considering the upper triangle here, has to be 180. So which means I could write theta is equals to 180 minus 90 minus alpha. So theta is going to be equals to then 90 minus alpha. Then I could write this one to be 90 minus alpha. So as the other one, this is also then 90 minus alpha, right? Then if I could find the x, guys, if I could find the x in terms of theta, and the D, I should be able to write something for the D in terms of X. Right? So let me put some letters as well, like P, Q, R, S, T maybe? Fine. How do I write the X? Well, I could do like this. Considering P, Q, R triangle. P, Q, R triangle. Who thought this to be a O-level maths class, right? Okay. I could write the tan alpha. How? Tan alpha. This is the opposite side. 115 minus x over 120. Right? Okay. But we already know how to write the tan alpha like this. From this triangle, I could write the sine alpha, which is 5 over 13, cos alpha, which is, tell me guys, 12 over 13, and the tan alpha 2, which is 5 over 12. So can't I write this one to be 5 over 12? I could be able to write, because tan alpha I have written like this. So usually the tan alpha is going to be 5 over 12. So it is 5 over 12 is equal to 115 minus x over 120. So this cancels off with 10, and this getting cross multiplied. So it is going to be 50 equals 115 minus x. So x is going to be equal to then 115 minus 50. It's going to be 65 meters. Right? Then I can considering RST triangle, this triangle, I could write something called, what's that? Maybe I could write, what's the trigonometric ratio that I could write with the dx and the theta? Dx and the theta. Sine, right? Because x is the hypotenuse, d is the opposite side to the theta, right? So I could write sine theta equals d over x. If I write with the colors, this will be the d. But we know theta is equals to 90 minus alpha. So sine 90 minus alpha is equals to d over x. X is 65. This is d. Yep. Then we are almost there, guys. What's sine 90 minus alpha? Cos alpha. Yes, it is cos alpha. How do you say so? Can you guys remember I told you about the quadrants? Right? This is from something called the vector. That's why I'm recommending you guys to watch that 8-hour class. So this is something called the cos alpha. That's O equals to d over 65. So what's cos alpha then? Yeah, we have already found that one out. That's 12 over 13. So 12 over 13 is equals to d over 65. And believe me, guys, it's your lucky day because 65 is divisible by 13. Exactly 5. So D is going to be equals to, what's that? 12 into 5, that's 60. That's how you find it. We'll draw it nicely and clearly as well. At the end, I'm gonna tell you a good story. So just copy it down. Defects. Uh, let's see. Defects at it's not there in the magical box. We'll request one from the front. Okay, thanks. Hold on, guys. By the way, don't break the window in the first day, right? I'm just joking. Yeah, if you are referring to this diagram, this is the P, Q, R, S, T. This is D. This is also the same triangle, PQR triangle. Finished using it? Thank you. There's the last part. Guys, if you finish this one, there's the last part. In the question, there's another part. Read the last part. It's asking what, calculate the time taken for this to happen. Calculate the time taken for what? Yeah, that means still the A is not moving, so the wheel follows this path. B should approach here at the point T. Right? The T කියන point එක approach වෙන්න ඕනේ by the B. So do you know the velocity of the B relative to A? Yep, we know that. So this goes with the, if we consider the relative velocity, this goes with 13 meters per second. How far it need to go? From P all the way to the T. So which means you should find out the PT distance and apply equation S equals ut along that path. S is the PT distance. U will be what? V B relative to A times the T. T is the thing we should find out. This is the, shall I put there? We'll leave it. You can put whatever the distance. It actually the PT distance. I could write dpt maybe. Find the PT distance. Well, now you can do it, right? Play with the geometry. So this is alpha. You could write whatever the ratio, sine, cos, tan, whatever. Can't you find this PR distance from the above triangle? Yeah, you can. Here we know this is to be 120 and this is to be 65. No. 115. Yeah, 15. 15. You all know all those heights. You can apply either Pythagoras or maybe a trigonometric ratio. Come on, guys, find it. Did you guys draw this triangle? Okay. How about the others? Finish drawing? I could write the cos alpha equals 1220 over pt. No, PR. Cos alpha is 12 over 13 equals 12 over 13 equals to 120 over PR. Oh, this is PR. Okay. Then this cancels off with 10 and the PR is going to be 130. That's PR from here to here. We should find the RT to you know the X, you know the X, also the D. Uh-huh. So yeah, can't you find the RT by Pythagoras? You could, or maybe you can put any other ratio. Whatever. You know the X, you know the D. You could find this, or else you can just write whatever. Like, 10, 10, 100, no, don't write 10 because it's going to fit that, but you can write the sign. So x is found to be 65 meters and d is found to be 60 meters. And can I erase this? Considering RST triangle, I could write this is adjacent, right? So adjacent over okay, cos theta equals cos theta equals to 1, guys. I could write st over sorry rt over rs cos 90 minus alpha is equals to rt, that's the thing we should find out, over rs. Rs is the x. What's cos 90 minus alpha? Cos turn into sine, right? 90 minus is cos turn into sine, so sine alpha equals to rt over x is 65, like that. Oops. So sine alpha is equals to 5 over 13 rt over 65. This cancels off with 5 and rt equals to 25 meters. Oh, blah. Therefore, uh, PT equals to 130 plus 25, so 155 meters. Coming to here, 155 equals, this is to be 13 into t, so t is going to be equals to 155 over 13 seconds. we have done so far, guys. So just divide it without being lazy. 11.0. Then don't tell it to be 11, right? It is approximately equal to 12, but just write 11.9 seconds. It's okay, good, good. Try, divide. Anushka, go to PA with the physics. Is it exactly 11.5, right? 11.5, right? 11.9, right? Okay. So I'm gonna have two stories. One is good and the one is bad. Which one you need to hear first? Right? There's one good story and one bad story. What do you need to hear first? Good one or the bad one? Bad one. Okay. So and the bad story is going to not actually bad, but that's going to be a good story for one and a bad story for just few people here, right? Well, this, right? Yes. So if I say about that, these are like 5 rupee lollipops for applied students because for the applied maths, they're gonna have a whole lot of I don't know, a whole lot of candies maybe, right? And these are just like few just simple calculations that they need to perform, and that's going to be I told you that right, some kind of relieving for the bio students, but the bio guys need to remember much rather than just doing these simplifications, right? That's the bad story, I think. Not in a bad way, but yeah, right? So are you guys ready to hear the good story then? Okay, great. So it's like this. So even though we have done these kinds of a calculation for the relative velocity, there isn't a single essay question that is being asked for the A levels since from early 19th up to the very recent year 2024, right? So there you can't find any past paper essay question came from just from the relative velocity. But there are just few MCQs that are being asked, not like this much of hard stuff, right? So you might wonder then what the heck is we have done, right? So here I encouraged you to think of something creative or think logically and also play with a little bit of the geometry. And we're gonna be using these kinds of things moreover because we have given one ratio. If you have given one trigonometric ratio, you're supposed to be able to draw a triangle and find the rest of the sides, and you should be able to write all the other trigonometric ratios, right? Except the math students, they have some special equations that they can use, converting sine to tan and tan to sine likewise, right? That CD formulas are there, 2 theta formulas are there, different formulas are there, they can convert here and there. But moreover, like for any students, you're supposed to be able to do like these kinds of stuffs, right? When we have given just the tan alpha, we found out just the tan alpha. From that tan alpha, we found out the other two ratios, sine alpha and cos alpha, using drawing a triangle like this, representing the alpha and how has to be the tan. And you're supposed to be have that sense. And the next thing is this, right? The vertically opposites and playing with the values, the lengths and the ratios. That's a must. and converting between the sine and cos with that 90 plus and 90 minus conversion, which I told you earlier, right? At least I'll just give that part as maybe bookmarking in the YouTube video, right? Just go through that part only at least. And next thing is thinking about like this, right? Like practicing yourselves to think some advanced concepts about this relative motion. If the two vehicles are moving and you're supposed to find where the minimum distance is, will you be able to do that without the relative velocity? No, never, guys, right? You won't be able to do. You won't be able to find this d here, which is the minimum distance, because the two objects are moving here. So how we can say which point the least distance comes? Either they at here, at here. We can't say so, right? But if you freeze one object, the relative motion describes everything relative to that frozen frame or stopped frame, right? So don't worry, guys. Physics is not this hard every time. There are some scenarios you need to do like these kinds of questions, and it is totally okay, like not being able to do this by your own. It's totally okay, right? And that is why the question I haven't given as a homework. Instead, I have discussed it within the class. So make sure you are not getting upset with me and also not getting upset with the subject, right? Or maybe the entire science stream, right? Don't think about it like that. These are kinds of like next level questions. And again, for the math students, this is supposed to be a piece of cake. Supposed to be, which means they're gonna deal with whole lot of huge calculations rather than this. Okay. All right. So since there's no essay question came up to the very recent year, you don't need to worry about too much about the relative motion, right? You could find some MCQs not in every year, unlike the linear motion parts, right? Unlike the motion under gravity, the projectiles. If you go through the previous past papers, each and every year you can see maybe at least just one MCQ from that part. But when it comes to relative motion, you're going to find some questions here and there, even as for the MCQs, right? But for the sake of completeness, oh yeah, I got frozen too in my camera. Okay, so you know, guys, how in this class works, right? We're gonna start with the very small problem, and we're gonna do to the very bigger ones. So you are kind of competent with any sort of problem that you're gonna encounter. Please make sure you go through this part once again, and I'm not going to make yourselves tired even more and more. I know that you guys are exhausted now. Maybe I could finish the class a little bit earlier. Uh, Maybe a little bit earlier, or else we could do one more question. If we are doing that question, we're gonna be trying the page 8, question 47, uh, and the fourth part. Shall we do it or shall we go? If you are good enough, we can try it now. We have another like half an hour, not actually half an hour, but 20 minutes left. It's 4:08. Shall we try it too? Okay. Do we need to have a vote? Okay. Shall we then? Okay. Just one question. 47. I just need to give a specific. You need to see there's a specific word, and that's why all I need to mention. මෙතන තියෙන එක පොඩි දෙයක් තියෙනවා අපිට ඉගෙන ගන්න එක. And the fourth part is kind of could be asked for an MCQ, and that's why I'm just asking you to draw it. You know, for the physics, sketching is something, a crucial part to visualize what's going to happen there, right? Sorry for interrupting all this, guys, but uh, you need to sketch it first, then identify the frames, name them, and mark the velocities as the notation that we have earlier used. Problem solved, right? Right, so let me help you with that, guys. I have seen someone has been taken it to be okay. So we need to write these, right? Velocity of river relative to Earth. I have named the reference frames too. That is equals to this side, 5 meters per second. That's the velocity of river relative to Earth, which means the stationary observer on the Earth. So what's that? 15 meters per second. That's the thing I should mention. Right? It's the velocity of board relative to Earth or relative to the river. That's the thing, right? So yeah, it is correct. That's the velocity of board relative to river. That means if the river is not flowing, the still waters means water is not flowing. In that case, he can ride to any direction if this river is not flowing down to the still waters. Still waters means if the river is not flowing. In that case, he can ride the boat to any direction with the velocity of 15 meters per second. So there you don't need to mark the direction because he can ride it downstream or maybe he can ride it upstream or any direction, right? So we should find the velocity of the boat relative to Earth, what's seen by the Earth, because with respect to the 2 points x and y, guys, they are the 2 points on the Earth, right? So I'm gonna consider the motion from x to y. X to y, what should happen? This boat can rode up to 15 meters per second if it's still waters, and the water is also flowing to the same direction. What will be seen by the person on the earth? Yeah, it will be 20. Now you know how to find it, but it's you don't need to write it, but I'm just showing it to you guys, right? Velocity of bird relative to earth, that has to be down, or maybe to this side, that has to be equal to velocity of, no, I'm just showing here the vectors, guys, not the direction, right? Velocity of bird relative to river plus velocity of river relative to earth. So in this case, it has to be the resultant downwards. So the velocity of boat relative to river will be 15 and to this side. How we say it's to that side? He can roll it to any direction now. But here it is 15. I have taken to the x to the y. Why? Because the boat need to be rolled from x to y, right? x ඉඳන් y ට යන්න boat එක ඒ පැත්තට right කරන්න එපා. එයාට ඕනේ පැත්තට පුළුවන් right කරගන්න. ඕන මෙහෙටත් පුළුවන් මෙහෙටත් පුළුවන් ඕනේ පැත්තට පුළුවන්. Right? Okay. Let's go to this side now 15 plus the river is also flowing to the same direction. So it is going to be 20 meters per second, right? That's how we're gonna see there because you have seen like the recent TikTok videos like you know. So in that in that case, guys, you have seen if the river is flowing downstream and if you ride a boat towards the same direction, we could have the velocity of the river plus our riding velocity. So you could go faster, right? Like this. So that is why you can't take it to be like s equals, you're having s equals ut, you can't take it to be 15 meters per second. When it's gone downstream, the velocity will be added there a little bit. So he's asking what's the total time taken. So for the x to y motion, I'm going to put s equals ut. So the distance will be 1000 kilometers. What's the velocity? That's velocity b relative to e into t1. So that is 1000 equals 20 t1. So this cancels off. T1 is going to be then 50 seconds. That's the time taken to reach from x to y. And then after you can find it from y to x using the same procedure. Now this 15 has to be to which direction? To the other side, because now the resultant has to be from y to x. Now it's not hard. It's going to be hard now because the water is flowing to this side. Now you are going to the other side. So your velocity will be reduced. Thank you. Do it quickly, guys. 8 minutes left. Okay, from x to y, then VBE equals VBR plus VRE. So now it has to be to this side. So now the 15 has to be this side, 15 meters per second plus 5 meters per second is to the other side. So overall to this side with 10 meters per second. So I'm going to apply to this side S equals UT. So that's again the same 1000. Now it is 10 into T2. So T2 is going to be 100 seconds. Therefore, total time equals what? T1 when going downstream, T2 when going upstream. So it is going to be 50 plus 100 and it is 150 seconds. Okay. With that, guys, we have successfully finished the motion part and also this tilt, right? Uh, so we're gonna see here at the very beginning. Now we have unlocked the 4 levels, right, of this game. Kind of like that. The linear motion has been finished. At the motion under gravity, we have finished that. Projectiles and also the relative motion, right? And as always, there's a cover story. You can go through that, right? And this is, by the way, the cheetah. I think you know, right? That is the fastest animal on the earth, the land animal who can run, right? And yeah, that's a story here. You can just go through, right? Same as the other ones. So next day, guys. Oh, I didn't mention any homeworks, right? So, so guys, for the relative motion, you can complete up the 47th question and the rest of the parts. 47th question, the rest part, and the 48th one, and the 49th one, right? And we have few minutes left. So, so as always in any tude, guys, you can find out a session called the solve problems, right? And there I have solved some of the problems for you in the page 10. And so why is it there? We just need to look at that. Okay, so I have solved that like that. No, right? So all you need to do here is just read the question, try your own self, right? Try your own, and thereafter see the solution. I've tried my best to provide the detailed solution for that one. So you can go through that one and correct yourself in case if you got wrong, right? And the MCQs, guys, about the relative motion, you could just find few MCQs at the page 15. Page 15, question 10, 11, 12. Yeah, that's all you can find out. And as always, guys, don't leave any tute aside without finishing it off. And there are going to be a whole stack of tutes at the end of the 2027. So make sure you have some space left for that too. And you guys, I will give the beginning tools. You can go through the vectors part. And as always, guys, if you are not confident enough with the vectors, that is really crucial. Go through that 8-hour class. If I say like 8 hours, don't be messed up, right? Just partition it and maybe watch it in the snack time. No issue, right? All right then. Thank you for joining the class today. Next day, we're gonna be doing the graphs on the motion, right? We're supposed to draw graphs for the motion, and we're gonna do it on the next day. So you're gonna receive a new tute too. Have a great week. We'll see you next week.